Okay, welcome back. This is our last little thing that we have to do with the limits of a function and continuity. What it is it's called the intermediate value theorem. The intermediate value theorem always pertains to continuous functions. So we're going to kind of go through what the definition says first, and then we're going to apply it to some problems. So the first thing I'm going to do is present my screen. So let me present to you my notes and share with you this. Okay, so what you should see is something that says Roman numeral 1, the intermediate value theorem. The first thing we're going to do is we're just going to write down the theorem. So it says if f is continuous. Okay, this is a requirement. You do need to know that f is continuous on a closed interval between a and b. Okay? Then the function f takes every value between f of a and f of b. Okay? So, suppose k, some random k, is a value between f of a and f of b. Then there is at least one number, and we're going to call it C, in between A and B, such that f of C equals K. Okay, so it's kind of a really long sort of thing, but there are a couple things you need to note in there. There are some things that have to be true before you can even apply this theorem. First of all, it has to be continuous. You have to be told that this is a continuous function. The second thing is we need to, at some point in time, make an assumption that there is some value of k between f of a and f of b. So let's kind of draw a picture of this, because I think it makes a lot more sense when we take a look at a diagram of what is going on. So let's kind of talk about this. First of all, you need to have some sort of graph, and you need to be given a function that is continuous. Okay? Notice, my function is f of x. Notice I did not pick my pen up. So the first thing that has to be true is it has to be a continuous function. Now, notice in kind of the description, and it's also on a closed interval between a and b. So I'm going to pick some arbitrary a on the x-axis, and I'm going to pick some arbitrary b, and I'm just going to make some dotted lines that kind of go to, actually, you know what, I'm going to use pink. So I'm going to make some pink lines that kind of go through this, and so now we have this interval between here and here. Okay? So we're just kind of breaking apart the definition. So it says, then f takes every value between f of a and f of b. Well, first of all, let's just note, f of a is right here. Okay? F of b, if I'm putting this onto the graph, f of b is right here. Okay? So what it says is this: every value between f of b and f of a, there's going to be some point on the graph that hits. Okay? So we need to kind of think about how this goes. So the second part starts kind of just adding in this random k. So let's just say there is suppose k is a value between f of a and f of b. So let's just kind of say k is any value that's somewhere between those two. Okay? What it is saying is that there should be, down here, some value of c that is between those two places. Okay? So what we end up with is that f of c will equal that value of k. Okay? So what we have is we just have a continuous function in between a set interval. And if we pick any random value between here, there should be some x value that will work in between a and b. Okay? So that is the intermediate value theorem. So let's go through and let's kind of start applying this. So let's apply this theorem to a couple of problems. So first of all, let's just draw a quick little sketch of this function, and it's just going to kind of go like this. Okay? Now, let me just kind of ask you a couple quick questions. What is required to apply this theorem? Okay? So there are a couple things that need to be required for this. The first thing is, one, it has to be continuous. So look at this graph, and as you can see, this graph is continuous. We also need to define some arbitrary or some distance between A and B. So I need to make sure that there is some closed interval, and I want to extend this a little bit, and make sure there's some closed interval A with some closed interval B. So in order to even do this, we have to have our values, our interval. We have to know it's continuous, and we have to know that there is some interval A and B. Now remember, that also tells us that this is going to be f of A, and this value over here is going to be f of B. Okay? So the two things you need is you do need to know that it's continuous, and you do need to have some closed interval that we are going to be working with. Now also, eventually we will have, we will need to know some value of k also. Okay, so we will need to know some value of k. So the first thing also is you need to also know where the k is. Remember, the k is not on the x-axis. The k is on your y-axis. Okay? And then remember, the c will always be, the c will always be down here. C is always on the x-axis. Okay? So, key things. There are some requirements that you need. The two key requirements are it needs to be continuous, and you do need to have some closed interval. When you find k, k does have to be a value on the y-axis. There also needs to then be, there will be some value of c that will always be found on the x-axis. So this is the theorem. So how do we apply this mathematically?